Okay, so here we go with statistics and probability, Payposit, self-paced, second lesson, so number 2. So we're going to do a quick review here for one slide, and this is if you're doing these back to back, this is the last slide you saw on Payposit number 1. Probability is the calculated likelihood that a given event will occur. Law of large numbers tells us the more stuff we conduct, the more trials we conduct, the closer our results get. And we have experiments, sample spaces, events, and outcomes. Right, so you should have reviewed all those for Payposit 1. Now we're going to get into doing some math, right? Because we're engineers, we do math with everything. So first thing is, if we want to do math with something, we've got to be able to express it as a particular type of number, right? We want to express it as a fraction or a decimal or a percentage or something so we can do the appropriate math with it. So let's talk about how to write probability as a fraction. What is the probability of a tossed coin landing heads up, right? So you guys have done this experiment. You understand what coins are. You understand when you toss them, they either land on heads or they land on tails. All right, so the way we write that as a fraction is we say how many desirable outcomes. So if we're trying to flip it to heads, right? Flipping it to heads is the desirable outcome. And how many possible outcomes, right? It's one or the other. It's either heads or tails, right? There's no third outcome when you flip a coin, right? I suppose you could drop it and not have any data, right? But that doesn't really count. So if your desirable outcome is 1 and your possible outcomes is 2, we make a fraction out of that by putting the frequency of the event that we want, right? The heads up coin on the top of the fraction and the total possibilities on the bottom of the fraction, right? So you all know that when you flip a coin, half the time you get heads, half the time you get tails. That's your theoretical probability, right? You've done that. You've probably used it for something to make a decision or something. I don't know. But you know it's 1/2. Here's how we get there, right? The total desirable outcomes is 1. The total possible outcomes is 2. That means that the probability is 1/2. And if you take that fraction and you make it into a decimal, that's 0.5. And if you take that decimal and make it into a percentage, that's 50%, right? So that's how we get the numbers that we can do math with probability, right? So let's take that another step. What's the probability of tossing a coin twice and having it land heads up both times, right? So I did a little coin tree here, a little probability tree. If the first flip right here is heads, and I'm just going to put a little arrow here, right? If this is my first experiment and it flips to heads, that's 1 time. This one is tails, so this is the one that I want to focus on because this is the one that worked out correctly, right? Worked out with heads the first time. And here's my second experiment right here. I can toss the coin a second time, and if it comes up tails, then that's a failed experiment because it didn't land where I wanted it to. And if it comes up heads, then it landed where I wanted it to. So this is the only branch of this tree that has heads and heads 2 times, right? So over here, heads, heads. This is the 1 desirable outcome out of 4 possibilities, right? So the probability of tossing a coin twice and having it land heads up is 1 desirable outcome out of 4 possible outcomes, or 1/4, which when you do math with it and you make it into a decimal, comes down to 25.25 or 25%. Okay, so I'm going to pause there. If you need to back up and see that again, then do that because we're going to add to it here. So a little bit more than simple probability this time. What's the probability of tossing a coin 3 times and having it land heads up exactly 2 times? Again, I have my experimental tree here, right? Probability of each time I flip the coin, is it giving me one of the desirable outcomes or one of the undesirable outcomes? Here's my first experiment, my second experiment, my third experiment. First flip, second flip, third flip. So I flipped this coin 3 times. I want it to come up heads exactly 2 times, right? So here are the possibilities for this branch of the tree. First one is heads, second one is heads, third one is heads, right? It did not come up exactly 2 times. It came up heads 3 times. So that is a failed experiment. That's not what I want. If I flip heads the first time, tails the second time, heads the third time, that is a successful experiment that has the coin heads come up 2 times, right? Same up here. Heads the first time, heads the second time, tails the third time. That's heads, heads, tails. That means heads has come up the 2 times exactly, right? So here's the key word here is exactly 2 times, right? If we wanted to come up at least 2 times, that's a different experiment, right? So have it come up exactly 2 times is like that. So heads, heads, tails, that's exactly 2 times. Heads, tails, heads, that's exactly 2 times. Heads, tails, tails, that's a failed experiment. It only came up 1 time, right? So just so you understand what the chart is doing here. So then at the end of the chart, I can look and I can see how many desirable outcomes did I have. I had 1, 2, 3 desirable outcomes. How many total possibilities did I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities right here. So I make my fraction. 3 desirable outcomes, 8 possible outcomes, and then I can do math with that. 3 divided by 8 is 0.375 or 37.5%. And typically when we do these calculations, we're going to use 3 decimal places, unless I tell you otherwise or unless there's a bunch of zeros at the end. Okay, it's going to be your turn in a minute. So if you need to back up and watch the video a little bit more so you can see how that worked out, I'm going to have you do the next experiment. And the next thing that I want you to do is to work out the answer to 3 decimal places for this Payposit question, which is the same type of experiment. I toss a coin 3 times and I want it to land heads up exactly 1 time, right? So up here, I had you doing it exactly 2 times and it was 3/8. I'm going to pause the video, or the video is going to pause on its own, and I want you to work out how many times it's going to land heads up exactly 1 time, right? So look at the experimental tree, etc. Work that out. Pause the video if you need to so you can see it on your screen, and then the Payposit is going to pause here in a second, and you can work out the answer. Okay, so you should have worked out your answer. We're going to move on to the next part, and this is where we're continuing to do math with probability. And there are 3 functions that we're going to get to here. One, the AND function, the OR function, and the NOT function. And these are important because next year when you take digital electronics, and everybody has to take digital electronics, you're going to learn about AND, OR, and NOT functions. Again, right? So it's going to be something that you need to know when you do digital electronics. This is your first introduction to it, right? The AND function is a multiplication function, right? And so we're going to talk about this in terms of rolling a dice, right? So what's the probability of rolling a 4 on a single dice? So I take 1 dice, I roll it. How many times am I going to get a 4, right? And that's going to be 1 out of 6, right? Because there's 6 sides on the dice, 6 sides on the die. One of them is a 4. So if I roll it, I should get a 4 every 6th roll, or 1 out of 6 rolls, I should get a 4, right? What's the probability of rolling a 1 on a single die? It's the same, right? There's only 1 side that has 1 dot on it, right? So that's 1 out of 6 times. And when I roll the die, I get the 1. And then we ask, what's the probability of rolling a 4 and then a 1, right? So I have to roll both of them. I roll a 4 and then I roll the 1. So the probability of rolling a 4 is 1/6. The probability of rolling a 1 is 1/6. What's the probability of I roll a 4 and then on the next roll I roll a 1, right? So the probability is 1/6 and then 1/6. And so when you're using the AND function, right, you multiply those 2 numbers together. So the probability of you rolling a dice and getting a 4 is 1/6. The probability that on the next roll you get a 1 is also 1/6. Now, some people think that it's different because it feels like, oh, I rolled the 4, now I'm less likely to roll what I want, right? But that's not really true. You are still just as likely to roll that 1 as you were to roll the 4. So 1/6 and then 1/6. Now the probability that you do them both sequentially is where the AND function comes in, right? So if I have to roll the 4 and then I have to roll the 1, you multiply those 2 numbers together. You multiply fractions by multiplying the top and then by multiplying the bottom. So that's 1 over 6 times 6, which is 36, 1 over 36. Work that out to decimals and then the percentages. 2.78 times, you can roll the 1, or sorry, roll the 4 and then roll the 1. Okay, so pause right here. I'm bringing up this word here called nomenclature, which is an SAT word. You should know it. Nomenclature means a way of writing something, right? So we're going to use this nomenclature for the rest of this unit. The big letter P here means probability, and the 1 underneath of it means the probability of rolling a 1, and that is 1/6. And down here, the big letter P means probability with a little 4 underneath of it, means the probability of rolling a 4. P1 means probability of rolling a 1. You multiply those things together. Right, so we're going to use that way of writing things, or that nomenclature, for the rest of this unit. Okay, the OR function. The OR function is an addition function, right? So what's the probability that I roll either a 4 or a 1 on one single roll, right? So the probability of me rolling a 4 is 1 out of 6. The probability of me rolling a 1 is 1 out of 6. So I'm going to add those two things together now, because that's the OR function. So probability of 4 is 1 over 6. Probability of 1 is 1 over 6. So I can add those two things together. When you add fractions, if they have a common denominator, you add the top, and then the denominator remains the same. So that would be 2 out of 6, which is 0.333 or 33.33%, right? Which kind of should make sense to you, right? Because I'm either going to roll a 4 or a 1. That's a third of the available numbers, right? So 0.33 is a third, right? Or 2 over 6, you can reduce that to a third. Okay. And then the last one is the not function, which is just the opposite of probability, right? So it's the 1 minus whatever the probability is. So what is the probability of not rolling a 1, right? So rolling a 1 is going to be 1/6. The probability of rolling anything that's not a 1 is 1 minus 1/6 or 5/6, right? So you can do that again as a decimal. It's 83% of the time you're going to roll something that's not a 1, right? And that one's maybe not used as often in probability, but it's something that you should think about. So I'm going to do the first. We're going to do 2 examples here. I'm going to do the first one, and then you do the second one. Answer it in Payposit. So what is the probability of flipping a heads 3 times in a row? Back to coin flipping, right? So what's the probability that I flip a coin heads 3 times in a row? So probability. So think about this in terms of ands or ors or nots, right? So it's the probability of flipping a heads and flipping heads and flipping heads. So 3 times in a row, heads and heads and heads. So we're going to use the and function here. Okay, so if I write this out as an and function, it's a probability of heads multiplied by the probability of heads multiplied by the probability of heads, which is 1/2, because half the time I flip heads and half the time I flip tails, multiplied by 1/2, multiplied by 1/2. When you multiply fractions, you multiply the numerator, you multiply the denominator. So I get 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, so I get 1/8. And I can make those into decimals by dividing, make that 0.125, which is 12.5%. So the probability of me flipping heads 3 times in a row is 12.5%, or 1 over 8, or 0.125, however you want to express it, it's the same thing. So your turn, what's the probability of flipping tails and then heads? So tails and then heads. So you do this one. Probability of tails is something, probability of heads is something. You're going to multiply those together. Give me an answer in decimal form. All right, so the Payposit should have paused to let you answer that question. And this one is practice number 2. What's the probability of rolling an even number on a single dice, right? So a single dice is 1 through 6. What's the probability of rolling an even number, right? So that's probability of rolling a 2 or a 4 or a 6. And you can probably think about what that probability is even in your head, but I'm going to show you how to calculate it. All right, so probability of rolling a 2, or, when we're talking about ors, we're doing the pluses, or probability of rolling a 4, or the probability of rolling a 6. right? So you know what the probability of each of those is, right? It's 1/6 each time. So 1/6 plus 1/6 plus 1/6. Adding fractions, if they have a common denominator, I add the numerator, which is the top part, and I put it over the denominator, which means the probability here is 3/6, which reduces down to 1/2, or you don't even have to do that. You can say that that's 0.5% or 0.5 or 50%. So the probability of me rolling an even number on a single dice, and you probably knew the answer to that when I asked it, is 50%, right? But here's how I get there from a math standpoint. All right, your turn. Whoops. Your turn is what's the probability of rolling either a 1 or a 6 on a single dice? 1 or a 6. So you're using the plus, right? So probability of 1 or the probability of 6. And you're going to answer that in Payposit. Give me an answer to 3 decimal places. And that'll be the end of our Payposit. Thanks for joining. I hope you were able to get all those answers. I will be grading those once they are turned in.